In this section, we're going to be solving square root equations. We looked at square root functions before, looking at their graphs and understanding their domains and ranges. And one of the big ideas is to remember that when we're talking about this, we're not taking square roots of negative numbers. These are square root functions, and so we're talking about only real solutions. So it's a step-by-step process, and it's easier to see with an example. But before we do the example, I wanted to talk about some words in here. Isolate the radical, where we're talking about that square root sign and everything that's in it. When we have the square root isolated, we're going to square both sides of the equation because squaring something and taking the square root are inverse operations. They undo each other. When we solve our answer, we are going to check our solutions. It's extremely important in these equations to check for what are called extraneous solutions. An extraneous solution is a solution that you arrived at through using perfectly good algebra, but when you plug it back in, it's not going to work. So let's look at several examples, and we're going to go through the same process on each one, and hopefully we'll run across some extraneous solutions to see. So example 1, square root of x minus 3, notice that's all under the square root sign together, plus 4 equals 9. Okay, so we're going to isolate the radical. We want that all by itself. See, we look at what's happening to it, adding 4, so we're going to move that, subtract 4 from both sides. I get square root of x minus 3 equals 5. Now, it's isolated. I can square both sides now. So I'm going to square this side of the equation and square this side of the equation. When we square a square root, remember these are inverse operations. They undo each other. So squaring a square root just gives me the radicand back, the thing underneath, x minus 3, equals 5 squared, which is 25. Now I can solve for the unknown. We're going to add 3 to get x all by its little lonesome, and we get 28. Now the really important part. We're going to check for extraneous solutions. In other words, we're going to plug it in. So we're going to come over here, and we're going to check our answer. Square root of 28 minus 3, then we're going to add 4, and it should equal 9. Square root of 25 plus 4 equals 9, and that is 5 plus 4 gives us 9. Yes, that one worked. Next example. I have x equals the square root of x plus 1 plus 5. Now I want to isolate the square root. Here's the radical. Here's the square root. I'm going to get rid of that plus 5. The opposite of adding 5 is subtract 5. So I get x minus 5 equals the square root of x plus 1. Now I need to square both sides of the equation. You're going to have to be really careful here. Squaring this side's easy, because squaring a square root, they undo each other, and we're just going to get the radicand back, just the x plus 1. Over here, do not fall into the bad habit. This is really x minus 5 times x minus 5. If you don't know your perfect squares by now, please multiply it out. Because x minus 5 quantity squared gives me x squared minus 10x plus 25. On the other side, when I square the square root, I'm just going to get x plus 1 back. Now, I have a quadratic. I need to set it equal to 0. So I'm going to subtract the x and get negative 11x. Subtract the 1 from both sides. I get 24. That's a positive 24 equals 0. Now, it'd be really nice, awesome, super if it's factored. Let's see. Can I think of some things that multiply to be 24 but add to be? Yes, I do. X minus 8 and x minus 3. Double check that. X times x is x squared. Negative 3x and negative 8x do give me a negative 11x. Negative 8 times negative 3 is a positive 24. So when I set each factor equal to 0, X minus 8 equals 0 gives me x equals 8. X minus 3 equals 0 gives me x equals 3. I have to check my answers. I have to check both of them. This is one of the problems that it's very important on. So I'm going to make a little line here. I'm going to start with 8. Let's check x equals 8. 8 equals the square root of 8 plus 1 plus 5. 8 equals the square root of 9 plus 5. 8 equals 3 plus 5. Is that right? It sure is. So 8 is good. Let's try 3. 3 equals the square root of 3 plus 1 plus 5. 3 equals the square root of 4 plus 5. 3 equals 2 plus 5. No. This did not work. That is why you have... Now, you came about it by using perfectly good algebra, but it didn't work when you plugged it back in. And I know you had Algebra 1 teachers that kept telling you to check your answers, check your answers, check your answers, and you may not have believed them. Now, from here basically on in this class, believe them. It's true. There are answers that come, you get to by perfectly good algebra, you didn't do anything wrong. But that answer doesn't work. So be very careful to look for that. Now, this problem is set up a little interesting. We have a radical on both sides. Well, is one of them isolated? It sure is. So just start with the process. We're going to square both sides. When I square both sides, when I square a square root, I get the radicand back. So 3x plus 2 equals 2x plus 7. Oh, that's nice. Let's subtract 2x from each side and get x. I'll go ahead and subtract 2 from each side and get x equals 5. But wait, I've got to check my answer. Don't get too excited there. Square root of 3 times 5 plus 2, that's 15 plus 2 is 17. See on the other side, 2 times 5 plus 7, that's 17. Awesome! That answer checked out. Last type you might see. Square root of x minus 3 equals 4 minus the square root of x plus 5. Ooh. Still, okay, do we have one of the radicals isolated? We do. So I can square both sides. Now I want you to be careful over here on this side. I'm going to actually help you write it out. The left side I know is just going to be x minus 3. That one's easy. Over here, you're going to mess up if you're not careful. 4 minus that thing times 4 minus that thing. Be super, super careful. So it's okay to do this one step by step if you need to. 4 times 4 is going to give me 16. 4 times negative square root of x plus 5 is going to give me negative 4 square roots of x plus 5. Negative square root of x plus 5 times 4 gives me another negative 4 square roots of x plus 5. And then here's a negative square root of x plus 5 times a negative square root of x plus 5. That's going to be a positive square root of x plus 5 squared, because we're multiplying it times itself. Now let's see what happens. We have an x minus 3 here, 16 here, a negative 4 times something, and another negative 4 sometimes something gives me a negative 8 times whatever that thing is, plus the square root of x plus 5 squared, which is just x plus 5. Now, we want to isolate the radical that's left. I'm actually going to move that one over to the left side and it would become 8 square root of x plus 5, because I'm going to add it to both sides. I'm going to subtract the x here, subtract the x there. I'm going to add 3, add 3. So over here I've got 16 plus 3 is 19. Then another 5 over there gives me 24. I almost have this one isolated. It just has an 8 on the outside. Well, let's divide both sides by 8. And I get square root of x plus 5 equals 3. Again, we have the square root isolated, so square both sides. And I get x plus 5 equals 9. So I get x equals 4. Not done. I know. Check the answer. Square root of 4 minus 3. Does that equal 4 minus the square root of 4 plus 5? Notice I put it in for every single x. 4 minus 3 gives me 1. 4 plus 5 gives me a 9. Square root of 1 is 1. Square root of 9 is 3. Does 1 equal 4 minus 3? It sure does. That answer worked. So, make sure you check every single answer.